Here's our first example of completing the square. I'm going to start with a quadratic equation for which I already know the factors and therefore the roots. The roots of this equation are 5 and -2. This is a good place to start because we know where we should end up after completing the square. So the first step is always to move the constant term over to the right side, and we'll do that just by adding that 10 to both sides. Our next step is always to divide both sides by the coefficient of x squared. In this case, we don't really have to do anything. I'll go through the motions anyway, because the coefficient of x squared is just 1, so a equals 1. Now the trickiest step is always in completing the square. And what we're doing is just taking half of the coefficient of x, so half of 3 is 3/2, squaring it and adding it to both sides. I like to just write it as 3/2 squared on the left, and on the right I'll just go ahead and square it, so 9/4. And while I'm over here, I'm going to go ahead and write that 10 as 40/4 and add it to the 9/4 to get 49/4. And of course all I've done here is just get a common denominator and add two fractions like we do all the time. Now the right side's all prepared, so we just need to identify our perfect square on the left. That's going to be x minus 3/2 quantity squared. And the way I've written it on the top makes it really easy to identify that perfect square. It's just the x variable with that sign and whatever's inside our squared parentheses. Okay, now I just take the square root of both sides to get x minus 3/2 on the left, and this turns out to be a perfect square, 7/2. And finally, I just solve for x by moving that 3/2 over to the right and finding my two roots. They're going to be 3/2 plus 7/2 and 3/2 minus 7/2. So that's 10/2 and -4/2, which is 5 and -2. And if we look up top, that's exactly what we were supposed to get.